Good morning. Today we'll discuss about how the simple harmonic motions can be added and subtracted. Before going to do the addition and subtraction of simple harmonic motion, let us discuss why we need to do this addition or subtraction on simple harmonic motions. So till now we have discussed or we have considered only one single harmonic motion, right? So if you consider x bar equals to a sine omega t or a cos omega t, we have considered only single harmonic motion. But in reality, do we get such type of situation where we will be getting only single motion? No, there will be multiples of motions at a time, or there may be, in fact, it may be an infinite number of motions at a time. It is possible. So in such case, what we have to do? We have to consolidate all the effects and we have to find out what will be the resultant effect of these motions. See, if again it depends on the phase angle. If they are in phase, your end result will be get added up, will be get enhanced. If the motions, if simple harmonic motions or simply motions are out of phase, what happens? The end effect will be get reduced. So how can you find if multiple of motions are happening at a time, and how you able to find out the end effect or end result due to the multiple of motions? So that we are going to do here. So instead of taking all at a time like 4, 5, 10 equations at a time or motions at a time, let us simply start with two equations. Let us consider two simple harmonic motions of same frequency but different amplitudes and different phase angles. So let me write the equations. So let me write the equation x1 equals to a sine omega t, then x2 equals to a1 8, a2 sine omega t plus 5. Remember here I am using simple harmonic motion sine function. You may take cos function also, you will end up with the same results. There won't be any change in the final answer. Right. Okay. So these are my two simple harmonic motion equations. Now what I have to do? Now let us go with the summation. So let me take, this is equation 1, this is equation 2. Now I want to do the summation. So what I need to do? x1 plus x2. So left hand side terms I am adding up. So the right hand side, what I need to do? a1 sin omega t plus a2 sin omega t plus 5. So I think you are very well aware of what the each and every parameter is. x1, x2 are the displacements of two individual harmonic motions. a1, a2 are respective amplitudes. Omega t is, what is omega t? The phase angle for the equation 1 or motion 1. Omega t plus phi is phase angle for equation 2. Now, okay, come for this. So here it is, I am doing the summation process. I am doing summation process. Now what happens? Simply expand the terms. You know, a1 sin omega t plus, it is in the form of sin a plus b, sin a cos b plus cos a sin b. So A2 sin A cos B plus cos A sin B. Now you segregate the similar terms. So sin omega t cos, sin omega t and cos omega t terms you segregate. So I am taking out sin omega t. So what will be the leftover here? A1 will be left over. In this case, A2 sin omega t is gone. So you will be getting cos phi plus similar way you segregate cos omega t into sin phi. So what is this? This is x1 and x2. Now instead of having these many different terms, I'll assume a1 plus a2 cos phi equals to cos theta, and we forgot here, it is a2 we forgot, right? A2 here it is a2 sin phi, a2 sin phi equals to sin theta, right? So I'm considering, so a1 plus a2 cos phi cos theta, a2 sin phi equals to sin theta. Now what to do here? Now substitute. Nothing to do. Substitute in this equation. So x1 plus x2 equals to what happens? Sin omega t into cos theta plus cos omega t into sin theta. Simply see, I am replacing this with cos theta. I am replacing this with sin theta. Am I right? Now, okay. Now, again, this is in which form? Sin A plus B. Sin of omega t plus theta. So this is x1 plus x2. Right? So now this is the final equation which you need to concentrate here. See, here amplitude, sorry, displacement of your resultant simple harmonic motion or resultant of resultant displacement of final motion is in which form? This is also a sine term. Nothing but if you are adding two simple harmonic motion, the resultant motion will also be a simple harmonic motion because you are getting a sine function. Sine function is a repetitive in nature and periodic in nature. So this is a sine function. So that you can conclude from here. So what is this? Now, right? Okay, okay. Right here we forgot this one. A, right? So A you can take common. So A you will be getting. So in this case, what happens? A will be the amplitude of your resultant simple resultant motion, and omega t plus theta is phase angle of resultant motion. Right. Okay. Now, now, now what you have derived? You have derived, you have proved that if two simple harmonic motions are added, the resultant motion will also be a simple harmonic motion. That is what you have shown or proved. Now, we'll find out the amplitudes and the phase angle. So, amplitude, resultant amplitude. So, what is that resultant amplitude? Yeah. How can you find out? See, we have considered these two. We want this. Whenever you have cos and sine terms, usually you remember to simplify what you have to do? Squaring of both the terms. So I'll do a cos theta whole square plus a sin theta whole square equals to. So what will do? A1 plus a2 cos phi whole square plus a2 sin phi whole square. Simple. I'm squaring of these two terms. Now, what happens? A square cos square theta, a square sin square theta. I'll common the a square. So, sin square theta. Now, a plus b whole square. A1 square, a2 square, cos square phi plus 2a1 a2 cos square phi plus a2 square sin square phi. Now, here it is a square equals to, simplify this, a1 square, right? Here a2 square, okay, and here. So a2 square is common. I'll take a2 square cos square phi sin square phi plus 2 a1 a2 cos square phi. So what I can write is a1 square plus a2 square, because it will become 1, plus 2a1 a2 2a1 a2 cos phi. Sorry. Cos square won't come, it will come only cos phi. Right, okay. So what is this? A square. If you want a, you can do under root of. If you want a, you can do under root of. Now, so what is this? This is the amplitude of your resultant simple harmonic motion. Now you want to find out the phase angle. So phase angle. So how can you calculate phase angle? So we here theta is the phase angle for the resultant simple harmonic motion. So in such case, what we can do? Whenever you have, if you want an angle, you have to do tan theta. So what you can do? A cos theta by A sin theta equals to A1 plus A2 cos phi by A2 sin phi. A will get cancelled. Cot theta equals to A1 plus A2 cos phi by A2 sin phi. Or else you can write even in terms of tan theta. Simply it is reciprocal of that. So theta equals to tan inverse of A1 plus A2 cos phi. So these are the amplitudes and phase angle of your resultant equation, right? So this is the theoretical or else, analytical approach, right? Now, instead of this, let us suppose you wanna do a subtraction. So here you have done the addition. So instead of this, you want to do subtraction. How can you do? Same story. Consider two equations. Consider two simple harmonic equations, which is having x1 a1 sin omega t, ax2 a2 sin omega t plus phi. Same story. But you are going to perform subtraction. So I am doing with red pen. Everything will come same, only the signs in between will changes. This is going to be a homework for you. So you just, so because of this what happens? Here it will get minus. So once you get minus, what happens? A1 sin omega t plus, okay, here it will get minus. So once you are taking out common, a2 sin omega t, right? A2 sin omega t cos phi, it will get minus. This will get minus. Oh, sorry, I won't remove that. So here it will get minus. Okay. Now what happens? A1. Sorry. A1 minus A2 cos phi it will become, right? So we will be getting, so you will be getting like this. Similar way, you do this, you will be getting the same answers for that, right? So this is how you can perform the addition or subtraction on the simple harmonic motions. Yeah. So now let's see how can we solve graphically this addition or subtraction problem. Let's take x, y. So what are those, what are our two simple harmonic motions? So let me write here x1 equals to a1 sin omega t. This is first equation, and x2 equals to a2 sin omega t plus phi. This is my second equation. And don't get confused, this is a different one. Okay, forget about it. Okay. So this is my equation. So now you know that this is the displacement, amplitude, phase angle. Now I'm drawing the first equation. So whose amplitude is A1 and whose phase angle is omega t. So let me take this as O, this as A. Now come for the second equation. Second equation is amplitude A2 with this phase angle, right? Let me take, this is point B and this is A2. And what is the phase angle? The phase angle here is omega t plus phi. I'm writing here omega t plus phi. What about this? This is 5. Okay, okay. Now, are you able to recall anything from your previous classes in mathematics? Yes, this is parallelogram's law. It is resembling parallelogram's law. Yes, so you have two sides of a parallelogram. If you try to complete the parallelogram, the diagonal indicates the resultant of the two motions. Right, okay. So how I can do? I'll parallelly draw a line of OA from B, point B. Here I don't have a sufficient space, so I'm drawing the approximate one. Now here I'll draw a line O parallel to OB from point A. Right? Somewhere these two will intersect, isn't it? Now if I connect these 2 points, origin and this point of intersection, so this indicates, the diagonal indicates the amplitude of my resultant motion. Now this, and the diagonal, the angle made by the diagonal with this OA will be theta. So what will be with the x? This will be omega t plus theta. So what is the phase angle? So if I write the equation for resultant equation, so x equals to x1 plus x2 equals to a sine omega t plus theta. So this is your graphical, this is how you can do in graphical method. Actually what you have to do, you are not supposed to do it on white paper. You have to use a graph sheet. Let us suppose you have 5 sine 30, right? So A1 is 5, nothing but you have to take either 5 units. It may be centimeters, it may be mm. So better you take in centimeters, that will be better. Okay, conventional way you have to take. So take 5 centimeters, you mark a line, you draw a line with this omega t, nothing but in our example we have considering 30 degrees. So in such case, what do you have to do? 30 degrees line, at a 30 degrees, you have to draw a line OA of this much of length. In the similar fashion, you have to draw a second line of this much of, at this angle of this much of length. So you have to use protractor, mark the angle, and from point O to through that point, marked point, you have to draw this distance. So you have to locate point A and point B. Now you have to use scale, roller scale, and you have to draw the parallel lines so that they will intersect at some common point. Now you have to measure this point. Let me take this as point C. Now the OC represents here a resultant's amplitude. So OC represents a resultant's amplitude. Now again you have to use the protractor in order to measure the angle made by this OC with OA. Either directly you can measure with the x-axis or you can measure with this axis, OA, so that you will get the value of the phase angle for resultant's motion. This is how you have to do. We have the problems, numericals based on this. We will continue in the next class. Thank you.